In this class, we will start to talk about nucleophilic substitution reactions. For nuclear substitution reactions, a Lewis base will act as a nucleophile to substitute for the halides on the carbon. So here the Lewis base will be something that has lone pairs of electrons that can donate the lone pairs of electrons, electron donors. We call it a nucleophile. So it will attack on the carbon atom with a leaving group. In most cases, it will be a halide. So this nucleophile will replace the halide. And this reaction is very important in functional group transformation, which means it can introduce many different types of functional groups into our system. So let's take a look at a very generic equation for nucleophilic substitution. We have Y here, that is the Lewis base, reacting with the Rx, an alkyl halide. So Y will attack on the alkyl group to replace the X. Okay, the product is Ry and X minus. So again, Y is called the nucleophile. Rx is the alkyl halide. Ry will be the product. And X here is the leaving group, the group that leaves from our alkyl chain. So I'm going to give you some examples regarding the functional group transformation. The first example, if the nucleophile is an alkoxide ion can replace the X, and the product is an ether with 2 carbon atoms attached to 1 oxygen. So when we have alkoxide as a nucleophile, ether is the product. The second example, if we have HS minus as a nucleophile, hydrogen sulfide ion as a nucleophile, it can replace X to give a thiol, RSH. A thiol is a sulfur analog of an alcohol. And the next example, cyanide ion can serve as nucleophiles. When cyanide replaces the X, it gives the alkyl cyanide as the final product. There's another name for alkyl cyanide. It's also called nitriles. Okay? And the next example, we have azide ion as the nucleophile. When azide replaces the X, it forms the alkyl azide. So here I gave you the Lewis structure of azide, but in a lot of cases, you will just see N3- for azide ion. Next, carboxylate ion can serve as the nucleophile to replace the X in alkyl halide. The final product is an ester. And lastly, we can have iodide ion that serve as a nucleophile to react with an alkyl bromide or alkyl chloride. And the product will be an alkyl iodide. This reaction uses acetone as the solvent. It's interesting that sodium iodide, NaI, as the starting material, it is soluble in acetone. And after the reaction, sodium chloride or sodium bromide as a byproduct both of these two products will be insoluble in acetone. So sodium chloride or sodium bromide will precipitate out of the reaction mixture, which will drive the reaction to completion. Okay, so the iodide ion reacting with an alkyl chloride or alkyl bromide in acetone, this can serve as a characterization method for alkyl chloride or bromide. And the positive test is the precipitation formed.